My name is Filipe Oliveira, and I'm a senior performance engineer at Redis, the company behind the most loved database. And today I'm here to discuss our end-to-end approach for performance testing, profiling, and analysis. To give you a little bit of context of who am I worked for Redis for about 3 years. My main focus is on continuous performance analysis and continuous performance improvement of the product itself and all the ecosystem around it. And apart from working on the performance of the database and on the models or products that sit on top of Redis, I also work as the open source contributor of multiple projects that are not fully related to the database, that are more related to the observability stack. Going through the agenda of today, so we're going to discuss a little bit what we mean by performance at Redis, our old behavior of doing performance analysis, what we learned from it, the new approach, and what we believe that we are still missing in terms of our future goals and our future capabilities. When we mean performance at Redis, we mean that we want to focus on fostering observability standards, fostering standards on how to properly measure the performance of the database. We want to be able to provide support to any of the contributors, both in the company and on the community, which means that we will basically tell them more on how to properly measure the performance of Redis, how to use standards to be able to do so, how to make sure that their environments are steady stable, and how to measure the variance of the results that they are getting. Bottom line, how to assess if the performance that they are getting is enough, how to improve it, and how to go from a regression or an initial state towards boosting performance of the database. Ultimately, we just want to optimize all the products that sit on top of Redis, the vanilla Redis itself, and we want to make sure that what we do is fully accepted by the community and is fully transparent. And to give you a little bit of context why we believe there's a lot to do in terms of end-to-end performance analysis, is because ultimately on our company products or any big open source projects, you can state that there's like full coverage in terms of functional testing. But when we talk about assessing if we've added a performance regression in an automated manner, nothing intercepts it. Meaning that the majority of the times we need to do manual testing, we need to do point-in-time checks between version A and version B, and this is exactly what we want to avoid. This is exactly what we are working on Redis as, and I'm fully aware of other companies also devoting a lot of time to this, because it's crucial to make sure that we remove the manual work behind performance testing and we automate as much as possible and we provide feedback as much as possible. And the reason behind it, and to prove how important this is, I brought a real case from 2019 from one of the products that we have at Redis, which is Redis Search, which is basically adds full text capabilities or secondary indexing capabilities on top of Redis. And on that 2019 task, it's a normal business as usual task for performance. The question was, we have two versions, an old version of Redis Search and a new version that we want to release, and we want to assess the performance. We want to make sure that what we're releasing is steady stable, is not adding any regression towards the previous behavior of the product, and ultimately, if possible, we want to optimize the new version versus the old one. This was a simple task, started simple, and as soon as we started measuring, doing the manual tests and manual checks between version 1.4 versus 1.6, we detected some regressions were introduced at the start, which implied that we iterated over multiple versions of the new version 1.6 to fix the regressions. And those iterations implied a lot of manual work, both from us, producing the result or running benchmarks, analyzing the results and producing reports to the engineering team, and induced a lot of stress on both the performance team, product and the engineering teams, because this implied a lot of manual work that was already at the last stage of the development of this new version. The information that we are, or the work that we are talking about, was extremely siloed, because we say, produce or focus on the testing, focus on the reporting and only when we got a full status we shared with the engineering team, which then took care of fixing or improving some potential points of improvement on the code itself. And we iterated over and over again up until we reach, ultimately we reached the final state in which we boosted the performance of version 1.6, version 1.4 by 64%. But this is not the focus. The focus is that we spend a lot of time. We had a lot of stress to produce these results, and we wanted to avoid this in the future. So getting back to, let's say, the initial statement about functional testing, in which we have like full coverage on performance, we don't have it, and given that we are doing point in time checks at the very end of the release process, we are basically just buffering potential issues. So we wanted to avoid it, and we wanted to move from the initial approach that we see on the left, in which we had some manual performance checks at the end of the release cycle, towards a new approach that fully avoided cycles, try to avoid as much as possible the manual work, which means that as soon as someone pushed code, for example, to GitHub, we started running the benchmarks based upon a spec that we built, without zero intervention from the performance team and even from the engineering team, which led to us getting the information from previously that took hours or even days for us to get, let's say, a performance status of a new build, towards minutes, at maximum 1 hour, to get the same information with zero manual work, with zero siloed information, because everybody is responsible for performance. So this was the goal: remove silos, ensure that there's as less as possible manual work, ensure that we have deterministic data so that we can trust the data, and ensure that as soon as we are able to measure performance, we are going to do it, instead of buffering all those code changes until we have we are at the end of the release cycle to do a performance check. That was basically the goal, or the set of goals that we wanted to reach. And this is not disruptive, or this part that I'm sharing right now is not new. So there are a lot of our competitors and partners that are focusing on the same stuff that we're focusing upon. So basically, we are all trying to remove manual work, all trying to share performance information as soon as possible and in the easiest manner as possible, and to give access to that data as fast as possible to the engineering teams, the ones that are responsible for improving the product itself. So to give you a little bit of examples in terms of the database world, we have Elastic that's sharing publicly the results and the evolution of performance of their product over time. We've seen in the same manner, and Mongo. Each one of them has different approaches and different maturities in terms of say several areas of performance. I would say that they are all doing a good job, and I'm pretty sure that the things that I'm going to share right now are disruptive in terms not the part of the performance testing, because that's basically the say homework that we need to reach, but we need something to be able to assess the performance. But then as soon as we get performance data to be able to explain it, I'm quite sure that we are doing something really interesting here, and I want to share with you what is it. So basically, our approach, or we said, given that we have multiple projects, each one of them, let's say with different sizes, we decided that we are going to approach this, and so starting by the small scale projects, because we can iterate a lot faster on top of it. That's why we've chosen Redis models, and we've partnered up with Intel and all of the members of the Redis developer group to be able to let's say create a standard that we all agreed upon how to properly measure or how to state if something in Redis is improved or degraded. We focused initially on open source deployments, not only because it's easy, but because there's a lot of we wanted the community to be able to reach out to us and to participate in this effort. So bottom line, to measure performance, or the performance measurement on Redis currently can be done not only by the members of the performance team of the Redis company, but it can be done by community members, other companies. They all can use the work that we are pushing forward within the Redis company, but they can measure it themselves. They can improve it, suggest ways of, let's say, further measuring the performance of Redis. It's all basically an open standard, and we are sharing it with anyone who wants to contribute. we wanted to focus on local and remote triggering of benchmark runs. What we mean by this is that we wanted to make sure that a developer had the capability to be able to assess if a benchmark that is producing, that is basically adding to the spec, would behave as expected in his local machine. We wanted him to be able to properly try out the new benchmark that is developing in the same manner that we do that approach when we were talking about functional testing. We wanted that exact same look and feel. We wanted someone to be able to properly trigger local and remote manners, trigger local and remote benchmarks in an easy manner. And we wanted to focus, this is the interesting part, and the part that I believe that's producing a lot of very good outcomes in terms of improving the product. We wanted not only to use this for regression analysis or for, let's say, performance testing from version A versus version B. We wanted to, as soon as we get those numbers, or as soon as we get an initial performance assessment of a specific workload on Redis, we wanted to start explaining why we are getting those numbers. And this is the really interesting part. That's the part that's making us proactively improve performance. But we're going to get through it on this presentation. So as I mentioned before, we started by open source deployments. And when I mean open source deployments, we're not just focusing on the standalone single process Redis. We're talking about multi-processor, multi-shard, multi-primary environments on Redis. So not only we are able to track the performance of a specific workload by branch, by version, but we can also answer any to any of the companies of the teams that are working on top of this end-to-end platform. How well does this benchmark or workload scales as soon as we start adding more and more primary shards to this to the environment? We ultimately will reach an inflection point in which adding more shards won't improve the performance, and that's where we start like fully devoting our analysis, understanding why are we reaching that inflection point, basically doing the hard questions from this initial data. As I mentioned before, our goal was to make quite easy or extremely easy to developers to be able to run a benchmark locally or to trigger a remote benchmark, assuming that they have the proper credentials on AWS. So this was basically how we, this is the same look and feel, or for you to be able to trigger a remote benchmark, you use the same make command with some set of extra environment variables, but it's extremely easy for a developer to trigger a local and a remote benchmark. And as I mentioned before, we are not only using this type of platform for testing or for producing benchmark numbers, we are also using it for profiling. So as you can see on the right side of this slide, on every CI or on every push to a relevant branch that we consider that should be measured the performance, not only we trigger the workloads, or not only we trigger the environments to properly run the benchmarks and to collect, let's say, the metrics to produce, let's say, evolution over time, evolution over version, etc. We also trigger the exact same deployment, but with a profiler attached to start explaining those numbers, to provide the next step to the developers that want to focus on how to improve that number that they are seeing, or that performance baseline that they are seeing at that current moment. Ultimately, for our approval process of a feature, for example, that the developer is pushing to GitHub, even before merging that code to a stable branch, or to let's say to the master branch of each of the projects, they can produce something like this. So based upon we provide this type of let's say automated data, in which they have like the baseline and the comparison versions for a specific project, and they can assess not only how did their change improve from the baseline version of the code, but also if the code or if the benchmarks that we are running are stable or not, if we can trust the data that we are seeing. And this is all automated. Anyone can produce this type of tables, and this is extremely important because it avoids, let's say, having a performance engineer focusing on producing these results. Only after we have the hard questions, or only after we have something interesting to look at, we start devoting manual time to this. Everything up until now is fully automated, and this basically scaled our way of doing a performance analysis within Redis. As I mentioned before, we're not just using this type of end-to-end platform for running benchmarks and producing the performance over time for our projects. We are basically doing proactive performance optimizations, and for that, as I mentioned before, we attach profilers to the environments that are running the benchmarks, or let's say to twin environments that are running benchmarks, because we are not using the generated profile numbers to track the performance over time, because as we all know, having profilers attached to a process or to a set of processes produces overhead, and we want to make sure that when we are profiling, this is just to generate content to explain the numbers. When we are running the benchmarks, it's just to generate the numbers that we use to keep track of the performance of the project over time. But focusing on the proactive optimizations, or what do we provide out of the box for developers in an automated manner. As soon as they add a new benchmark to the benchmark suite of that specific project, they will get a full process frame graph and the main thread frame graph. Both of them are important for the Redis related workloads. So basically, they are able to see what are the top call stacks for the specific workload and decide or start making the questions if what I'm seeing right now on CPU, or what's consuming the majority of the CPU cycles, is what should be consuming the majority of the CPU cycles, or are we detecting some hot path that shouldn't be present. We also provide you a more holistic or a more general overview in terms of from all of the shared objects that are consuming CPU cycles, which one is consuming more. So instead of going by function, in here we go one level above and we tell you, okay, this shared library is consuming 49% of the CPU cycles. In this case, it was the Redis time series model, and 40% was being consumed by the code within Redis itself, and then we had 6% on standard library, etc., etc. So bottom line, this should be used to be able to properly assess or easily assess if devoting time to improve a specific code within the project that I'm working would be the best approach to improve performance. Let's consider that we would be in here, instead of having 50% of the CPU cycles on Redis time series, we would have 10%, and we would have 60 or 70% on the Redis server. So it would be much more interesting for us to devote time optimizing the code within Redis server, because the potential impact would be a lot larger than to focusing on improving just 10% or at max 10% of the CPU cycles given that was the total amount of CPU cycles that's being spent within the project that we are discussing. So this is a very easy manner of understanding if a specific workload is easier or not to optimize, or if we should focus on redesigning the entire approach for that specific workload. We also provide, in the same manner that we provide a frame graph, we provide a table, which is the same look and feel, but just in a textual format, providing what are the top the top consumers by function, before it was by shared object. And we go one level down and we provide you based upon each, what's the top consumer by line of code. Instead of by function, we provide you the by line of code consumer. Ultimately, if we detect hot path, we also provide you a hot path code graph, telling you exactly what's the top consumer, or what's within all of the functions of my project, what should be the hot path that I should focus upon. We can check, let's say, live examples or previous examples of this approach, in which we start by analysis, and we started after we gathered this entire data. We said, okay, now it's time to optimize based upon the data that we saw. We did change A, B, and C on the code, which impacted by 47% the total, let's say, the total CPU time of that specific workload. So you can check it out. You can check out these links. Those are live examples of how we use the information that we are fully collecting, or that we are collecting in a fully automated manner, to proactively optimize some of our projects. So bottom line, doing a summary of what we've gained up until now, up until this stage, in which we move from manual performance testing to a fully automated performance testing that scales a lot better than the previous solution. So we basically moved from having a feedback cycle or a tedious feedback cycle that took place to up until 1 hour. Let's say we can even have shorter feedback cycles, because this is fully automated. responsibility of adding more and more performance coverage to the projects is now not only responsibility of the performance team, but given that this is so easy to add new benchmarks to each of the projects, now it's everybody's responsibility. So when we're talking about developing a new feature of the product, you can easily add a way of keeping track of the performance of that feature that you are working on, even before merging to a more stable branch. So you can basically, while you're working at developing the functional feature, you can start adding performance tests and assessing how performant it will be, assessing if there's any code change that you can do right away to improve the performance. So it's very easy to add tests, which implied basically that our way of scaling, or our previous limitation in terms of being able to scale performance work, was completely removed. So now everybody is helping in terms of adding more and more benchmark coverage, which ultimately provides us given that we are collecting much more data, it's a lot easier for us to do a proactive optimization of the performance of each of the projects. Given that we stopped focusing on these, manual tasks that were a little bit tedious in terms of that were a lot time consuming, we were able to focus on more challenging tasks, which means that the performance team is a lot happier, days are completely different than they were before. We are working on something or on things that really matter. We are working on projects that are much more research situated, and we can still do our previous job, but in a faster manner, in an automated manner, and we are able to focus on the more challenging stuff that ultimately will provide further performance improvements to the product. And as I mentioned, now finding performance problems or potential points of improvements, it's a lot easier. It can be done not only by the performance team, but by anyone looking at the code or maintaining the code of Redis or any of the projects that we are discussing. So this is a lot more interesting, not only for us, but for developers that have much more capabilities, or that have yet another added set of tools to their to their toolbox in terms of software development. Given that this is fully automated and that we control the environments that we are running on, and we control the hardware that we are running on the benchmarks, we can very easily provide answers to the questions like, I have a new family of, for example, AWS machines versus an old family of AWS machines. How is Redis going to behave on this next generation of, AWS VMs? Am I going to benefit from moving from the old generation to the new generation? By how much? We now can very easily quantify performance and can start answering these type of questions without having a lot of manual work and a lot of potential manual error as well. Given that we have continuously benchmark scanning as part of our CI, as expected, we have continuous up-to-date numbers in terms of performance. We don't need to do any manual point-in-time check. And given that this is open and this is working fully based upon open source, products, we can share how we are doing it. We can be fully unbiased in terms of what's the performance of Redis for the specific workload A, B, and C, and we can use this to properly, share performance data with the community. What's next, or in terms of this is the current state. What do we expect to gain next months? So basically, we are focusing on the profile data. It's deeply focused on kprof and perf. But given that we work with multiple hardware partners, and we are working, we have much more tools that we can use to give us data that is completely unknown. So we want to extend the profiling tools that we use. We want to extend to provide data not only on the CPU and based upon on the CPU analysis, but to off CPU analysis. We want to be able to tell you if the trade configurations that you have for the specific workload are basically being fully used, or if you are over provisioning any of the resources that you are using. We want to focus upon what's impeding that specific workload from further improvements on performance that are not really related to one CPU, but like off CPU locking. And ultimately, given that we have all the tools to be able to start providing more and more insights to developers, we don't want to stop here. We want to reuse the information from compilers like let's say the automated vectorization reports, and why did we vectorize or not a specific portion of code. We want to fully we want to provide and automate the ability to reach developers for a specific workload, to tell them, okay, for this workload, the code or the top CPU consumer code for that specific workload is not fully vectorized. There's something that we can do better. Please look at this off-CPU analysis, please look at this vectorization report, and this is not currently in place, so we want to focus upon it. Ultimately, what I've been discussing up until now is that we basically want to add more and more visibility to the unknowns that we have right now, and we want to completely remove them and to be able to fully explain the numbers that we are getting for each of the workloads that we are adding to when we talk about measuring the performance of Redis. Let's say on a more general approach, we want to increase the persons that are using this end-to-end platform. We want to reach to the community, to anyone who wants to contribute and wants to extend the benchmarks of Redis or the way we track the performance of Redis. And we want to basically feed this continuous up-to-date performance data and expose it as part of the documentation instead of having static charts that explain how is Redis scaling or how does Redis behave for a specific workload A, B, and C. We want that to be fully automated so that we don't have like stall and old data as part of our documentation. And that's it. I hope that I basically, provoked the sparkle on you with regards to performance and with regards to the Redis performance. And if you want to know more about how we are developing this end-to-end performance analysis tool, which is fully open source, reach out to performance@redis.com. Or if you want to work with us, to fully devote your work time to this type of projects, we are hiring across multiple positions within the performance team and even across multiple positions within Redis itself. Thank you, and I hope to see